So I'm Min Ragan-Kelley. I work on IPython, and I'm going to give my talk with IPython. I recently graduated in physics from Berkeley. I still work at Berkeley, now funded by the Sloan Foundation. I get to work on IPython all the time, which is really nice to be able to work on open source software as my job. So just to get a feel for the room, who here has used IPython? Okay, who here has used the IPython Notebook? Okay. Who here, to bring in Rubyists, who here has used Pry? Anybody? Okay. And does anybody actually type Python at the terminal to use an interactive Python session? Okay. And IRB, anybody actually use IRB? Okay. So IPython came into existence, I guess 11 or 12 years ago, when Fernando Perez was doing his PhD and doing some Python analysis and just got fed up with the interactive Python terminal and needed a better interactive shell. And so to first order, IPython is interactive Python. So I can define functions, I can run them, I have output, I execute them, I get results. Results come back, as they arrive. It has what you expect from an interactive experience. It has tab completion. One thing that the current architecture, the two-process architecture of IPython is, so my interface, in this case, is a web browser. We have multiple input modes. The interface is not actually in the same process where the code runs. One of the consequences of this is that I can, this is a little bit of code that will segfault. But when it segfaults, it just says, oh, it just restarted, and then I'm actually fine. But you'll notice the prompt came back to 1 because the process came back, and it came back with the in a fresh state. Fault is too small? Yeah. How's that? Better? IPython is a little bit more than Python. We extend the syntax a little bit for special commands, so we add a question mark that introspects, I probably can need a little bit bigger, introspects the function. So I just did linspace question mark, which brings up information about the function linspace. So this is the doc string, has parameters, and the function signature. So it's useful for exploring packages and kind of learning as you go. Because the people who work on IPython, we're all scientists, we're doing research, which, as various people have said, Einstein and Wernher von Braun, research means we don't know what we're doing. So we open a terminal, we know kind of vaguely what we want to use, but we don't necessarily know how to use it, and things like question mark and tab completion help us get through that. We also have shell interaction, so if you start a line with bang, then it'll execute the shell command, so you don't have to type out os.system or subprocess.call and all these things. You can just type ls, which makes it a little bit more useful for interactive work because you can just look in the directory. You can do assignments to the output of shell commands. And then the second thing we add to IPython syntax is this thing called magics. So if you start a line with the %sign, then it will run what's called an IPython magic, which has this kind of a cell-like, can have a shell-like syntax for running just simple things. It's a shorthand. It transforms an expression into a corresponding Python call. And time it, if you've ever written profiling code with the time it module, it's a little bit verbose. You have to write a little block of code, and time it lets you do that in a slightly more efficient way, and it automatically picks, based on how long it takes, it automatically picks the number of cycles it should take. And this is a useful way of saying which which approach should I take? Sometimes you say, I want to insert, I want basically the front side version of extend of a Python list. There isn't a front side version of extend, and there are a variety of ways to write that in Python. And with timeit, you can just write them all and then run them and see which one's fastest and pick that. And it's a really nice, easy workflow to get through, just figuring out which thing you want to use. Some more magics. This is just a simple couple functions that result in dividing by 0, which is an error. So we have a debug magic, which gets me a PDB prompt. So I can look at X, I can walk up the stack, I can look at Y, I can look at the backtrace, I can leave the prompt. And we have quite a few magics. So this is just a magic that lists what magics are available. And you can see information about magics. Say I want to look at autocall. I can look. What it does is it will add the parentheses. If you get too comfortable in the shell-like environment and you start forgetting to write your parentheses on your Python functions, if you turn on autocall, it will add them for you. But I'm clearly not in a terminal right now. The environment this is a web browser. So in a web browser, I can do more than just a plain REPL. I can run code, and I can do more than print statements. So the first thing that we add is rich display. So matplotlib is essentially the standard plotting library in Python, and it is a wonderful thing. And what we do is integrating matplotlib with a special inline backend that's actually part of IPython. When you make a plot, it just shows up inline in the notebook. So the plot generates a PNG, sends that over the network, and then we embed it right in the page. We also have LaTeX. I don't know if these are going to be familiar equations to people who aren't physicists, but here's Maxwell's equations. And this is what's called a cell magic. So a cell magic with the two parentheses means take this block of text and pass it to some Python function to do something. In this case, it's just display LaTeX. And to this rich display functionality, libraries, so SymPy is a symbolic mathematics library. They have this init printing function, which tells SymPy to tell IPython how to display SymPy objects. So I just create this expression, x to the 10 minus 1, and then the actual repr, when sys.displayHook gets called on the expression, I actually get the LaTeX math for x to the 10 minus 1. And then I can factor that, which gives me another expression, and it gets LaTeX rather than the plain text representation. And another library that is working with IPython is Vincent, which is a Python plotting library that wraps the Vega JavaScript library. So I create some Python data, and then I create a Vincent bar graph, which when I display that, takes a moment, depending on my network connection, and it creates this plot actually with a JavaScript plotting library, Vega, which is built on D3. So in this case, I just actually published the numbers, the actual data to the front end, and then the front end called the appropriate JavaScript to draw the graph in the page, rather than drawing with matplotlib, which draws a PNG in Python and then just sends the image. And the result of this is that you should be able to get more interactive plots and things. And then we have simple literals for shorthand for embedding images, doing simple HTML as output. So bringing all these extensions and rich display things together, IPython has extensions so you can define, and an extension is just a Python module that defines a function that can modify IPython. And in this case, our magic loads a magic, or a few magics, for working with the language R in a separate process. So with matplotlib, I can create a little data and plot it with matplotlib. But I can also, with R, with this $R, all of this is actually in the language R. And this will be passed off to the R process using RPy2, and I actually send the data, X and Y, locally, send that to R as X and Y, and then I can actually do plots in R. And from R, I even get the plots that were generated by R come back into IPython and back into the notebook. But in this notebook, we also have, it's not just code. It's not just code input and output. We also have Markdown cells. So you just write Markdown, and we run math jacks on the page. That means you can embed math. We render Markdown with the marked JavaScript library, which means it supports a certain amount of GitHub-flavored Markdown with triple backticks and pipe tables and things like that. And so it's all rendered browser-side. So now I've been working in the notebook, but what actually is a notebook? So we save, and then this is showing some of our variable expansion in a shell command. So I'm just calling head in the subprocess. And I created a Python variable, and then I'm expanding the Python variable in the shell command. And you see the notebook is just JSON. It's just a really simple JSON structure. This is the actual file on the disk. And cells, the first cell is a heading cell. So this is our H1. And it has, has content, markdown cells. And I have a code cell, which has input, and then it has outputs. So it's a very simple structure of encapsulating the input and the output and the text and everything in a simple document. And one of the reasons we have this as a simple structure is that we now have a tool called nbconvert for converting notebooks to other formats. So if I just call nbconvert and then to HTML, I can open that, and then instead of the dynamic page, I just created a static HTML version that I can share. So now I've just got an HTML document that I can show you all my code, my input, my output. I can share this, so you can show your code, your actual results, and all your documentation about it. You can share that with someone, and they don't even need to have IPython in order to be able to at least read it. And we have a service called nbviewer, which just runs this. You give it any URL to a notebook on the internet, and it will download it, run nbconvert, and show you the static HTML page. So, which has been useful for sharing work, sharing notebooks, little demos, snippets of code, scientific analysis. An nbconvert can convert to multiple formats. It can do LaTeX output for PDFs. It can do restructured text, Markdown, to pure Python script, and rich HTML, and it's all templated with Jinja, and the language, the various format conversion is all done with Pandoc. So one of the other things is I can export this notebook to a reveal.js slideshow. So this is actually the notebook that we're looking at right now as a slideshow. So you can do presentations from it. The slideshow version doesn't have interactive code, so I can't execute. But interrupt the subprocess. So what actually is IPython under the hood? How does this all work? And essentially, when we started coming up with this two-process model, which was mostly for dealing with the segfault problem and dealing with the remote execution, right? We want to have the interface somewhere and the code runs somewhere else. And so what we had to do is, since IPython is basically a REPL, is we had to write REPL as a message protocol. So we have a very simple message protocol with JSON messages of message types, and they have content and different keys that is kind of RPC-ish that we send over 0MQ to communicate with the kernel where the code executes. And it's just a bunch of of little messages that are very straightforward and easy to understand. We send the notebook talks to a web server with WebSockets, and then the server talks to kernels, multiple kernels with 0MQ. And it's actually quite straightforward. Simple little messages, but you'll notice that in these messages, so then I can this is a Python code cell that actually executes JavaScript in the web browser. So this just grabs the kernel object and then executes Python code as a string, and I can print A, right? So just to prove that I wasn't lying. Right, so I just, in Python, execute some Python code that sends JavaScript, that executes JavaScript, that executes Python, and then show the result that actually happened in the Python side. And we have a public document describing this whole message protocol. There's quite a few messages. And you'll realize that there's nothing actually Python specific about a REPL over the wire, right? You're sending code as text and you're getting results that are MIME type output. So if there's nothing Python specific about it, then why don't I implement a kernel in maybe a different language? So no, there's nothing Python specific about it. So this iRuby started as a project for a weekend project by a guy who had basically never written Python code, just looking at our message spec and implementing a basic Ruby kernel. And then just in the last couple weeks, which has helped me out here, a guy, Daniel Mendler, has taken over and added a bunch of awesome stuff to the iRuby kernel. So now this is all Ruby. And if you look at the IPython config, the IPython configuration that enables a Ruby kernel instead of a Python kernel, it's just this. When the command to start a kernel, you just say iRuby kernel. And that's all you need to do. And then it passes a connection file so that it knows how the ports and everything. And then I set the port so that I wouldn't keep loading things on conflicting ports. And if you look at the arguments that started this process, it is indeed, it's just iRuby kernel and then the connection file. And iRuby implements a lot of what IPython does. So, when you return something, it comes in with an out prompt. When you have something that's actually an image, a file image, it just displays it inline. Has a display method for displaying inline HTML. You can display iRuby math and LaTeX. Because, again, you're just sending the LaTeX to the browser and MathJax is rendering it. And iRuby has a table primitive, which IPython doesn't. This is something that iRuby has that IPython doesn't have, and has these table primitives that render as tables. In IPython, typically, if you want tables, you're going to be using a tool called pandas. And Pry is a wonderful, Pry is kind of like IPython for Ruby. It's a better interactive shell that is focused on debugging, which adds some syntax. Like I can look at the methods on file, and it shows me a little summary of methods, class methods, parents. And with the RMagic gem, this lets me create a little image, and I can display it. Ruby Viz does some JavaScript plotting. And Gruff, simple Gruff plot. Right? So I've got I've implemented a kernel. It's a simple project at the Ruby kernel. It's fairly small. And another kernel. This is another language called Julia, which is a language for doing numerical computing, mathematical computing out of MIT. And they have what was really the first real full kernel for IPython in another language. And it's a cool language. It has basic input and output. It has output caching just like IPython. So if you address out to, that actually gives you the value that's next to the prompt. You can create matrices, display them in a reasonable summarized format, because that's a big matrix. Can print to standard out and standard error. I can call directly printf in C. This is something that actually doesn't work in Python, in IPython. We don't capture the output of printf. That will go straight to the terminal. But we will capture Python print statements. And in Julia, there's a library called pycall that lets you call Python from Julia. So I just imported scipy.optimize, which is a Python package from Julia, and I just called it. And then pyplot is a Julia library that actually wraps the matplotlib plotting library. This is a really great thing because nobody should have to re-implement matplotlib. Matplotlib is just in a class of its own for doing publication quality plots, and essentially no matter what language you work in, you probably want to use matplotlib to generate your figures. And you want that to be as easy as possible from the language you're working in. And in Julia, thanks to the work of Stephen Johnson, that's actually remarkably easy. And so I just created a plot in matplotlib in Julia, and then it came back through Julia as my figure. And then it has all the same, multimedia display. I can create a class, an HTML type that with a literal will display. And then there's a difference between display and then printing. Okay. And that's kind of a summary of what IPython does, what IPython is, and how you can, you can write your own kernel for Clojure. There's a Scala kernel, there's a Node.js kernel, but those are really toys at this point. But it's certainly for an expert in any language, it is no great undertaking to write a kernel for the IPython Notebook or a kernel for IPython, and then you get all this notebook sharing capability and everything for free just by implementing the protocol. And that's about all I have to say.
Thank you very much. Questions?
Yeah. Great talk. Thanks. So first, are the slides? I mean, is the notebook available somewhere?
Yeah, it's minrk/RuPy. And then I posted actually the MB convert output. Let's see. Yeah, so that's the repo, and then this is the output. Oh, that's odd. I trust github.com. That's weird. Oh, no, it's just because I typed a stupid S. Yeah, so then this is the NB convert output as static, served on GitHub pages. So you can see the notebooks even if you can't run them, and you can download them just from GitHub.
Okay, thanks. And the second thing, I know that lately you've been working a lot on bridging JavaScript and Python in the notebook. So I'm wondering what's the roadmap here? Can we expect maybe some better, more powerful integration of JavaScript visualization in the notebook?
Yeah, so that's what we're working on right now in IPython is just about ready to merge is basically what we call a communicator that lets you create your JavaScript objects that have a special pipe to your own Python side objects, and you can send messages of your own design back and forth. And I can do a demo of an example of that lets you do interactive plotting I have a demo with Flot with that, and then we'll have some basic primitives for simple HTML5 controls that let you move a slider that actually changes values in Python. Yeah, that's our main milestone for the release in this winter. And it's the first prototypes are open PRs, just about ready to merge. I just have to get home so I can review them.
Questions? More questions? Well, sorry.
So it's really cool that you support all these different languages. There's two languages that kind of came to my mind. One is all the examples I've seen so far seem to be mostly dynamic languages. Is it any more difficult to add something like Haskell or something statically typed?
So what you would need to do, the most important thing about the two, about iRuby and iJulia, is that they're not actually by the IPython team. And that's an important sustainability issue for maintenance, that we just provide this message specification, and then the Julia guys wrote iJulia, and various random volunteers have worked on iRuby. So basically, if you can take a message and then do something with it in a way that makes sense in your language, then it will work. So you may write the kernel in a different language, that like Python or something, and then you actually, when you handle an execute message, you do with some C API or something, call the eval in some compiled language or something. You could have a C kernel. Using Python, you could write a kernel that's actually C, where all the code you type is actually C, and then you implement the kernel in Python, and then with a tool called Python, you compile it and then you execute it. So you could do it in just about any language, but some languages may have runtime restrictions that make it not reasonable. But it's certainly easy in any interpreted language. That's where it makes the most sense, right? But
so the other question is JavaScript.
Yeah.
So a couple years ago, I had this project where I made a REPL for CoffeeScript, and it wasn't nearly as cool as IPython Notebook, but one of the cool things about it is you didn't really need a web server of your own, so you could just log in, you could connect to different services, use APIs, whatever, delete all your Google Calendar events in one command, or do anything
yeah,
more.
so I actually, we have 2 toy JavaScript kernels. One that uses Node.js in the backend, which has the whole multi-processing structure, but there's also one that I wrote where I just short-circuited the kernel JavaScript object, where instead of connecting WebSockets and everything, kernel.execute just does eval. And so you can actually extend the JavaScript to not use a remote kernel at all. You can have a local kernel in just plain JavaScript.
That's really cool.
It's a bit wonky how you have to get that, how you have to make that work, but it does work. And then with the notebook server, the only thing you would use the notebook server for is saving the documents, that kind of stuff, but not for code execution.
More questions?
That is, we were sprinting on that before I flew here, so that should be next week. It's pretty much ready now. Yes, no, I know. It's yeah, it's been a partially done PR since May, and it's about ready now. So look for it in the next week, probably.
Anyone else? Well, then, thank you very much for this interesting talk.